Joelle, it is wonderful to have you here today. Thank you so much for taking part in this series of interviews where we are getting to know some more of our editors for the journal Chemical Engineering Research and Design. So as always, we always start these interviews with an opportunity for you to introduce yourself. So tell us a bit about yourself and the work that you do.
Okay, thanks, Bradley. So my name is Joelle Aubin, and I'm a chemical engineer by background. And I did my undergraduate chemical engineering degree in the University of Sydney, and then came to France as a university exchange student in the final year of those studies. And while I was there, I had the opportunity to have an experience in research, and it made me want to do a PhD. So I ended up doing a master's and a PhD in France, but my PhD was also under a joint supervision program with the University of Sydney in Australia. So I got a double degree in chemical engineering.
Was that?
And
I was just going to ask, was that one of these so-called co-tutelle arrangements? You ended up with like the diploma from both of the institutions.
Exactly that. Yeah. So I was one of I think the first one at the University of Sydney to go through that program.
Marvelous.
So, yeah, and then since then, I managed to get a full-time research position with the French research agency, the CNRS, and so I've since then been working as a full-time researcher in chemical engineering at the University of Toulouse.
That is wonderful, and for those viewing this video, you and I had a little chat before we started this formal part of the interview because we discovered that we're both Australians living and working here in Europe. Joelle, I congratulate you on getting a full-time permanent position with the CNRS. For those people not accustomed to the French work and funding system, that's a competitive achievement. So well done. To end up with a full-time permanent position in the CNRS is fantastic, and you're at one of the very top chemical engineering schools there in France. So it's wonderful to see you as a chemical engineering research and design editor having great impact there, but also yay, another Australian chemical engineer having a great impact there in Europe. So very good. Can we talk a little bit now about your research and your work? So I was told by Catherine Cliff, who works for our journal from IChemE, that you actually started in one section of the journal, I think heat and mass transfer, and now you've moved over to the fluids section of the journal. Is that right?
That's right. So I was invited to be just one of the editors in heat and mass transfer quite a few years ago. I can't remember how many, but it's been quite a while. Although my real area of expertise is in fluid flow, but at the time they needed people in heat and mass transfer. So mass transfer is of course part of my expertise, heat transfer a little bit less. So I started out like that, and then there was people retiring, other editors retiring from fluid flow. So I did a stint where I was taking papers from both, just because I had requested that I would have preferred to be in fluid flow.
Yep.
And then just since September, I am now topic editor. So Jos Duxen has retired from that role, and I took over from him. So I'm now managing the papers that are coming in and distributing the papers out to the other editors in fluid flow.
Super. So for our readers and for our authors, just can you very quickly describe this kind of workflow? So a paper from an author gets submitted to an online system. Boom. What's next?
Okay, so when the paper is submitted, most often the authors will choose a topic. So, heat and mass transfer or fluid flow or process systems engineering or something else. So when it gets submitted into fluid flow, I am sent the manuscript to decide whether it is well adapted to the journal, if it's the right quality, right standards. And either at that stage, the paper will be rejected if it doesn't meet the standards of the journal, or if it's out of scope. Or in the other case, I will accept it to go out for a reviewing process. So then I will send it to one of our editors within the topic, and they will then assign reviewers and deal with the review process.
Super. And I know, because I've been at that sort of level below you as a subject editor, that they come down fairly quickly. So I imagine you turn this around fairly quickly. You see these quite regularly and you decide fairly quickly.
Yeah, there's probably between 8 and 10 that come through in a week.
Yep.
Catherine Cliff won't send them out to me all in one go. There might be 3 and 3 and 4 or something during the week, or and depending, it's not always 10, but it's.
Thank you for explaining that, because that's an interesting thing for our authors and maybe for our readers to know a little bit about just how many stages and how many people are involved in getting a manuscript through this reviewer process. How about your research, though? I kind of cut off your talk about your research because I wanted you to address this topic of how a topic editor works. What research are you doing there?
Okay, so my research focuses on understanding fluid mechanics, mixing and transport phenomena in all types of chemical engineering equipment. I've got a big background on stirred tanks.
Okay.
But more recently, we've pushed towards process intensification. I've been looking at other types of continuous flow reactors, microreactors, millireactors, continuous oscillating baffled reactors, some centrifugal reactors and things like that. So it's really a question of trying to understand the links between equipment geometry and operating conditions with respect to process performance.
Cool. And both experimental and simulation, or?
That's right. I really try to push the use of one tool over the other, depending on what type of information we required and at what scale. Sometimes you need, not very detailed information to correctly design a device, but then you might need very detailed experimental or numerical information at the scale of a bubble or mixing phenomena or something like that to understand the underlying science. So I will choose one over the other or a combination of both to get the right information at the right scale.
And can you give me an example of something you've done that you thought was really just cool or unique or original, like something with traces or something in the microfluidics? What's an example of something that you think is just, it was just fun and cool to work with?
Well, I really like using CFD to get 3D data and being able to play with the data and be able to. You can just do so many things. I think lots of people forget about the power of data, and I think it's probably going to improve with data science, becoming so popular at this stage. But typically people, when they show CFD results, they just show some vectors in a 2D plane. But there's so much more you can do, and I love, for example, using massless tracer particles and tracking the flow. And putting and monitoring different values at each of these the traces over time, and so you can just make them like a digital sensor, and then you can do statistics and a whole bunch of other things. So I like that. I do like experimental work as well, but I love playing with the data.
Super. And you touched very briefly on this topic of data science. So one of the newest editors who joined our journal is Arthur Schweitman, and he's working at Delft, and he has interest in machine learning, but also big data. And many people that I talk to see it as something really important and as the future for not just our research, but for our publishing as well. So do you have any takes on that? Where do you see, for example, CFD and fluid mechanics going with big data? Because I totally agree with you. I've seen the publications where someone's done a great simulation, but all you get is a PDF and some 2D or maybe 3D static images in a PDF. And other than what they tell you, you don't get anything else from it. You don't get their simulations. You don't get the output from their simulations. So what do you think is the way forward from your perspective?
Well, I think that, I mean, today data science is, is really becoming a big thing, with machine learning and all of that, because we now have the computational resources to do it. But I think that it's not going to go much further unless we have the creativity that goes with it. And I think that's the hardest thing, is trying to say, okay, what can I do with this data? And to get out of, the locked way that we were, we learned previously. And that's always very hard. I mean, people, you just think, okay, it's hard to change and hard to get it out of it, out of your head. Okay, I can do things differently. And it's, I think, we'll easily be able to go and do lots of things with this data, but the hardest thing is really going to be to have that creativity and find new ways to look at it. And I think encouraging people to look in other areas of science can be really helpful sometimes.
Exactly, because I think some of our colleagues that come from different backgrounds, especially the computational backgrounds, they're much more familiar with some of the tools. So I worked with a colleague recently who we did, very, very large number of 2D computational simulations. And he showed me a great way to present it, which was basically a web page with a 2D graph on it, and basically 2 parameters extracted from each 2D plot, forming the X and Y coordinates on this graph. So you've got a scatter plot, but then if you hover on any one of these points, it pops up the 2D image of that simulation. And actually then you can click on it if you want and download that 2D image. So in one sort of easily navigable web page, it's HTML, it can be run locally or it can be put on a website. You can present basically the output of a week's worth of CFD simulations on a supercomputer cluster that people can at least extract things from it. But this guy was not a chemical engineer. His original training wasn't in chemical engineering. He was a data scientist, and so he was much more familiar with these ways of presenting huge data sets in reasonably interactive and useful ways that people can at least get some feeling for what the data is saying. Because just sharing an archive of 3 gigabytes of PNG files is really not much use to anyone, because like you say, the creativity to represent it in a way that people can interact with and extract something from it is that missing link there. So Joelle, what do you find rewarding? What are some of the positive aspects that you find working as an editor for chemical engineering research and design?
Yeah, well, I think I've been involved in CHERD for a number of years now, and I haven't wanted to, retire from these types of roles, because I do really enjoy it. I enjoy being able to have a vision on, a global vision on research over a broad research area, networking with different people. Even though we don't necessarily meet, but there is exchange via email sometimes, and you get to know names, and then you see papers, written papers, and so I do enjoy that networking in that way. And in terms of what tips for authors, what I would really like to stress, and what I look out for when I'm, screening papers, is impact of papers. The authors really should start to look at, and think about how their results and their conclusions are going to impact the chemical engineering community, and how those conclusions will fill the gaps of the current science. Very often authors forget about this, about identifying gaps in the knowledge and then focusing their research to fill the gaps. And so that's what I would encourage authors to do.
Super. Very good tip. Thank you. So Joelle, thank you so much for your time in the interview today. Are there any last comments or encouragements that you'd like to share for the chemical engineering community?
Well, look, I think chemical engineers have a big place in the world, even though we often people don't know what we do really. But it is a very practical engineering vision of multi-scale science and multi-physics phenomena, and we deal with a lot of problems. And lots of other scientists sometimes think that chemical engineers are kind of just do a bit of cooking in the background, and and we're jack of all trades. But I think it's very important because as chemical engineers, we may be different than other engineers in the fact that we can often accept to look at a large scale or a very small scale, and to choose what scale we look at depending on how we need to design the process or the industrial application.
Joelle, it has been an absolute pleasure to meet you today over Zoom, to get to know another originally Australian working here in Europe in chemical engineering, and to hear especially about your research, your long-standing work as an editor for the journal, and a little bit about your vision for the future. I wish you a Merry Christmas. Stay healthy. And I hope that we meet in person at some time in the future, maybe at one of the European Chemical Engineering conferences.
Well, that's right. There's one in Berlin that will have to be in Berlin in 2 years' time. So I think in 2023, right? Yeah. So okay. Well, nice to meet you too, Bradley.
Great to meet you too. Take care and bye now.
Yeah, bye now.